Okay, we're still on Pinocchio. This is part 2 of Pinocchio. I'm on problem 23 here on the back side of the first page. We're doing the limit at infinity right now. We have a fraction where the bottom's getting bigger faster than the numerator, so that's headed to 0. And now the remaining stuff that you're looking at here, I have to put a million there, I guess, and a million there. But this, like we talked about earlier, is the dominant term. And the dominant term controls the shape of the graph. So that's the guy that we use to figure out what's happening as you go left or right forever. So we only need to stick a million into this part of the equation. So a million squared is a very large number, multiplied by -2 is a very large negative number. So now we are back to negative infinity is where this graph is headed as you go to the right forever. Some of you view that as an upside down parabola. That's not quite, but it does give you an idea of where the graph is headed as you go to the right forever. On 24, it's up to you now when you have fractions to find that dominant term. The dominant term will be, for now, the largest exponent you can find. And right here, you'll see it's this guy, x to the 5th. X to the 5th is much bigger than anything else in this equation, so as you stick in a million and a billion and a trillion, that guy right there is going to get bigger faster than anything else. And when you have a fraction that has the denominator get bigger faster than anything else, then that fraction's getting closer to 0. If you look at 25, we have a dominant term of x squared, which is in the denominator. As we go to infinity, the denominator is going to get bigger faster than anything up there. We get closer to 0. 26, the dominant term is located right there. The x to the 4th term is the biggest exponent we see, which means when you stick a million in, we're going to put a million right there. To the 4th power is still positive, times +5 is still positive, so we've got infinity. However, we now have to watch out for this. The dominant term on the top means that the numerator is going to get bigger faster than the denominator, which means it's going to be one of the infinities. But we have to look out for the sign, S-I-G-N, of the dominant term on the bottom. Here's what I mean. If you look at 27, it's the exact same equation as 26, except we're doing the limit as you go to negative infinity. So the dominant term is still located there. If you were to stick in a negative a million right here and raise it to the 4th power, it would be a giant positive number. Times 5 is still a very, very large positive number. But keep in mind, we're going to stick negative a million right there also. So it's this huge, enormous number divided by negative a million. And since we have to go to negative infinity, that guy right there is always going to be negative. It's going to be a much smaller negative than that positive up there. But what will end up happening is you'll have a giant positive divided by a smaller negative every time, which means this graph is headed to negative infinity because a positive divided by a negative is negative. Alright, turn it over. And let's go ahead and this first part recaps what we've done. So I'll kind of go quickly. The dominant term on number 2 here is the 5x cubed. So when you stick in a million, you only need to stick a million into that guy and you would get infinity. The dominant term on number 4, the largest exponent, don't forget to grab the coefficient that's in front of it. So -7x to the 6th, stick a million into that. You would do a million to the 6th power, which is a very large positive, times -7 is a very large negative number. The dominant term here is the 3x, and when the dominant term is in the denominator and you're going to the infinities, that fraction is getting closer to 0. Now, some of these look okay. I wanted to talk about before I run out of time. Let's go to 9. 9, here is your dominant term. Now, remember, when you're doing limit at either the infinities and the dominant term is in the top, the answer is going to be one of the infinities. We just have to figure out whether it's plus or minus negative infinity. To do that, we plug a million into that dominant term and we figure out what type of number do we end up with, which is a very large positive number. We plug a million into the dominant term in the bottom to see what the sign of it is. You plug a million right there, you get a positive number also. So a positive divided by a positive is positive infinity, so that's what we would go with on number 9. On number 12, which is the same equation where you have to plug in negative a million, well, plugging in a negative a million into the dominant term up there will give you a very large positive number. But plugging in negative a million into the dominant term on the bottom will give you a smaller, but always a negative number, 4 cubed. So a positive divided by a negative will give you a negative infinity. Let's look at 14. Plugging in negative a million, we have a fraction that's has the denominator getting bigger faster than the numerator, so we've got that headed to 0. That 3 is staying put. We don't have anything to plug in there. We have to plug in negative a million right there. Negative a million divided by 6 is a very large negative number. If this seems confusing, now plug in negative billion, negative trillion, negative quadrillion, etc. You can see as that gets a very huge negative number, this 3 becomes irrelevant. This controls the shape of the graph. And a very large negative divided by 6 is still a very large negative, so negative infinity would be our answer to 14. If we look at 15, plug in a million, here's our dominant term. Whenever the dominant term is in the top, it's going to be one of the infinities. So if we plug in a million right there, a million to the 4th power is a very large positive, times negative 4 is a very large negative. If we plug in a million right there, a million to the 3rd power is a very large positive, times negative 1 is a smaller but always negative number. So a negative divided by a negative in this case is positive infinity. Alright, the other one I wanted to look at, oops, you should be able to do all these now, I hope. Number 6, though, is cosine, and if you recall, cosine starts up there and it does this and it goes forever. Limit says what y value does this graph approach as you go to the right forever. Well, if you were to slide to the right and it's always fluctuating like this between positive 1 and negative 1, then the graph is not approaching one particular y value. And since it's not approaching one particular y value, we're going to say that the limit does not exist for a cosine graph, which would be the same for a sine graph, which has the same wave. But watch out for equations that have trig functions. Don't just put does not exist next to them. For example, cosine of x, no matter what you plug in for x, will give you a value that's between 1 and negative 1. So keep in mind that the number up here, as you slide to the right, is always between negative 1 and positive 1. Well, if you were to put a million right there, you're going to get some answer that's between those two numbers. That answer would be divided by a million. Now put in a billion. You'd get something between those guys divided by a billion, etc. This guy's getting huge. This guy's going to a billion, a trillion, a quadrillion, going to infinity. But this guy's always staying between negative 1 and positive 1, which means that's the dominant term. That guy's getting bigger faster than that guy is. And since that guy's getting bigger, the denominator is getting bigger faster than that guy, that fraction is headed to 0. So the answer to 7 is 0. I have time to do one more, so let's just grab one down here just to make sure we're okay. Maybe we can do 2 more. I have a typo here. I have 2 13s. So if you were to look at the first 13, find the dominant term. The dominant term is located right there. Hopefully you recognize when the dominant term is in the denominator at either of the infinities, that fraction is getting closer to 0. And this is just one big giant fraction, so we just put equals 0. As opposed to 13, 13 has a dominant term located in the top. When the dominant term is in the top, it's going to be one of the infinities. Now we have to check the signs. Put a negative number right there. A negative number to the 5th power is still negative. Times 4 is a very large negative. Your dominant term on the bottom is this guy right here. So put a very large negative right there. To the 3rd power is still negative. Times negative 5 is back to positive, which means we're going to have a very large negative divided by a positive number every time, which means our answer is negative infinity. Okay, I hope that gives you enough to finish the ditto.